Hello and welcome you all. Dear students, this is quick revision session for DC to DC converters. DC to DC converters are also called choppers. It is a device which converts fixed DC which is applied at the input into variable DC at the output directly. Such choppers or such devices are applicable in voltage regulator circuitries like SMPS, or they can be also applicable in case of battery charging circuits. So first is, there are two major types, step down and step up chopper. This is the circuit diagram of step down chopper with R load. From the exam point of view, we may expect the question like this: draw and explain the operation of this step down chopper with R load along with suitable waveforms. This is pretty simple operation. We are using one switch. This is electronic switch. So let us assume that the switch is closed for certain time period, that is called T on. Whenever the switch is closed, whatever input DC is there, that will be directly available at the output, say up to time period dt. D is called duty cycle, which is defined as T on upon T. T is the total time period. Now after dt we will open this switch. जैसे मैंने बताया, स्विच जब क्लोज होगा तो ये पूरा वोल्टेज यहाँ पे आ जाएगा. After dt we will open the switch. Whenever the switch is open, you are not getting anything at the output, so output will be 0. Again, after T on and T off, this T is total combination of T on plus T off. After this, again the switch will be closed and the cycle repeats. This is the voltage waveform. This is corresponding current waveform. Amplitude of current will be reduced because current is V0 upon R. Next part is step down chopper with RL load. Only major difference is that instead of R, we have shown RL load, that is inductor is shown. Now this is electronic switch like the earlier case. Whenever switch is closed, this FWD, freewheeling diode, will be reverse biased, and whatever source voltage is there, that will appear directly across the output. So you're getting this type of waveform at the output. But this is inductor, so current increases exponentially from minimum value to maximum value. Whenever switch is open, the circuit will be switched off and you are not getting any output voltage across RL, that is V0 will be 0. But inductor has stored energy initially, so this stored energy will be again returned back through this path. I mean through this FWD. This will freewheeling diode will act as a short circuit, and the path will be completed, and you are getting exponential decrease in the output current from I0 max to I0 min. So this is about step down chopper with RL load. Next part is step up chopper. We have just now discussed the step down chopper. It is opposite operation. So this is the corresponding circuit diagram. In this case, the major difference is that here Ls is the large value of inductor which is connected in series with the supply voltage Vs. This is the switch which is a chopper switch. We know that it can be designed by using IGBT, MOSFET and so on. This is FWD, freewheeling diode. This is the RL load connected at the output side, and across RL we are supposed to measure the V0. There are two modes of operation. First, switch is closed. Whenever the switch is closed, then this part will act as a short circuit. Due to short circuit, entire current will flow through this branch and no current will flow through FWD and through this output RL. So output voltage will be 0. बहुत सिंपल है. जब यह स्विच क्लोज हो जाता है तो शॉर्ट सर्किट की वजह से यहाँ पे कुछ करंट नहीं जाता है, सो आउटपुट voltage is 0. Similarly, output current is also 0. But inductor, this is an inductor, large value inductor. So inductor started storing the energy, because of which the inductor current increases, let us say from I1 to I2 like this. This happens during T1, that means during the period when the switch was closed. Next interval, when the switch is open. If the switch is open, then this is open circuited. I will write it over here, OC, open circuited. Then this path will be completed through this FWD, that is freewheeling diode, then through this RL and so on. That means whatever energy that was stored by the inductor will now start traveling through this FWD and through RL. So in case of inductor current, the current decreases from value I2 to I1 exponentially as shown in this figure. Some current started flowing through RL, so you are getting some output voltage, that is V0, during T off time period. T off is the period when the switch was open circuited. So this is the corresponding waveform of voltage and current. So, and this is about the working of step up chopper. As far as the problems of this chapter is concerned, for step up and step down converters, this is the list of formulae. This is sufficient to solve any numerical. First formula is V0 average. This is D. D is the duty cycle into Vs. Vs is the supply voltage or voltage connected at the input side. This is the generalized formula. If you have step up converter, step up chopper, then the formula is Vs upon 1 minus D. In some numericals, the voltage across chopper might be given. In that case, use this formula. So for given chopper voltage drop, use the formula Vs minus Vch. Vch is voltage drop across chopper. That will be given in the question into D. D is the duty cycle. Second formula is V0 RMS. RMS output voltage. Generalized formula is root D into Vs. If chopper drop is given, then it becomes root D inside the bracket Vs minus Vch. Duty cycle formula is T on upon T. T on is on time period. T is the total time period, which is combination of on and off time period. Output power is Vs minus Vch bracket square upon RL. RL is the resistance connected at the load into D. Input power is Vs inside the bracket Vs minus Vch upon RL into D. Efficiency is P0 upon P in into 100%. To get an idea, let us solve a numerical. A step-up chopper is used to deliver load voltage of 500 volt from 220 volt DC source. Means this average value of output voltage is given, that is 500 volts, because it is mentioned delivers load voltage, so it is given value of average output voltage. And this is thyristor, and it is supplied from 220 volt DC. That means value of Vs is 220 volt DC. If blocking period of thyristor is 80 microsecond, blocking period means value of T off time period is 80 microseconds, and we know that micro means 10 raised to minus 6. So 80 into 10 raised to minus 6 seconds. Compute the turn on time period. T off is given, we have to calculate T on time period. Now let us first calculate value of D. This is the step up chopper, so we have to make use of this formula because V0 average and Vs is given. So from this formula I can write V0 average is equals to Vs upon 1 minus D. From this I can write 1 minus D is equals to Vs upon V0 average. Simple है, ये दो terms interchange किया, then D is equals to 1 minus Vs upon V0 average. Again, D is transparent at this side and this term is transparent at the LHS, and then LHS and RHS are interchanged. So from this we can calculate value of D. 1 minus Vs. Given value of Vs is 220 volt upon V0 average, that is given in the question, that is 500 volt. Therefore, if you solve this on the calculator, value of D will be 0.56. This is the value of D. Now make use of the generalized formula. D is equals to T on upon T. This is the generalized formula to calculate the duty cycle. ये formula यहाँ पे available है. T on upon T, and we know that this T is total time period, which is on time period plus off time period. So first I wrote the general formula T on upon T. In place of T, then I have put the value T on plus T off. Out of this, the value of off time period is given, that is 80 microseconds. I will keep it as it is, so that answer will be again in microseconds. I am not going to convert it. So this value I can write it as T on upon T on plus 80 microseconds, and we know that value of D is 0.56. So let us simplify this. In place of D I will write 0.56. Now consider first term and these two terms, take the cross multiplication. So 0.56 T on plus 0.56 into 80 is equals to T on. This is 1 T on as such. So I can write this as ये अगर टर्म ये यहाँ पे ट्रांसफर करेंगे, so this becomes t on minus 0.56 t on is equals to 0.56 into 80. So if you do this calculation on the calculator, you will get value of t on is equals to 101.819 microseconds. So this is the answer of on time period. Likewise, if you know this list of formulae, you can attempt any numerical related to step up and step down choppers. Next topic is control strategies for DC choppers. That means what are the different techniques used to control the output of DC choppers. From the exam point of view, you may expect the question like this. Explain along with suitable waveforms the different techniques used to control the output of DC choppers. Broadly, there are two types of techniques. One is time ratio control, which is abbreviated as TRC. Second is current limit control, abbreviated as CLC. In case of time ratio control, TRC, again there are two types. One is constant frequency, second is variable frequency. This technique is pretty simple. Recall the things. Duty cycle is given as T on upon T, where T is the total chopping time, and this total time is combination of T on and T off. So T is T on plus T off. In first method, constant frequency method, T on is varied. That means this value is changed, but T is kept constant. The शेष diagram में देखो, this is the value of T on. This time period represents T off. So this is the total value of time T. Look at the second diagram. In this case, T on is changed. T on is varied. It is increased up to this point, but this T is kept constant like the previous case. So in this case, T is kept constant. T is reciprocal. T is the total time period, chopping time period, and it is reciprocal of frequency. Since T is constant, frequency is constant, so it is called constant frequency. And in this case, the width of on pulse is varied, each changed. So this is also called PWM technique. Second is variable frequency method. As the name indicates, frequency is varied. That means we have to vary T, keeping either T on or T off constant. In this case, T on is kept constant as shown in this diagram, and T is varied. जैसे देखो यहाँ से यहाँ इस पॉइंट से इस पॉइंट तक टोटल T है. So in the second diagram, this T is reduced. This value of T on is kept constant. That means we have kept T on constant instead of keeping T off constant, and total T is varied. So accordingly, the output voltage can be controlled. This is called frequency modulation. This is diagram में दिखा है T on is kept constant. We can well keep T off constant. The next type of control strategy is type B, that is current limit control, CLC. As the name indicates, two reference values of currents are used. One is I0 max and I0 min. बहुत simple technique है ये. This is the graph of output current. The output current, let us say, start increasing from this I0 minimum value. When it reaches to I0 maximum, then the switch is turned off. तो यहाँ से off time period start होता है. When the switch is turned off, the value of current goes on decreasing, goes on decaying. When it reaches to I0 minimum, this is the value of I0 minimum. ये I0 minimum का value. When it reaches to I0 minimum value, again the switch is turned on. This is the on time period. Again the switch is turned on and the current starts increasing. Same cycle repeats. When it reaches to I0 maximum, again it decreases and the switch is turned off. This is T off time. So this is the way how the current can be used to control the output of DC choppers. These are the corresponding output waveforms. Whenever chopper switch is on, you are getting Vs at the output, and whenever it is off, the output is 0. So this is about the current limit control strategy. Next part is types of choppers based on the quadrant in which they are operating. So this is the classification. Exam point of view से हम लोग ऐसा question expect कर सकते हैं कि what are different types of choppers depending on the type of quadrant in which they are operating, and explain any one type in detail. So this chart gives the types of quadrants. Roughly there are three major types: single quadrant, then two quadrants, and four quadrants. In case of single quadrant, There are two types, class A choppers, class B choppers. In case of two quadrant, again class C choppers, class D choppers. In case of four quadrant, only one type is there, that is class E chopper. These are the corresponding diagrams. In case of class A, the chopper operates in first quadrant. This is graph of V0 average versus I0 average. V0 average is output average voltage, I0 average is output average current. So ये graph first quadrant में, in this case voltage as well as current both are positive and the transmission of power is unidirectional from DC source to the load. Second is class B. Again, it is single quadrant operation, but it is in opposite direction. So in this case, voltage is positive, but current is negative. यहाँ पे zero है, तो इस side में current is negative. So here you are getting minus I0 average value. Therefore, the power transmission is unidirectional, but it is now from it will be in reverse way compared to the first case. So it will be from load to the DC source. Next is class C and class D. These are two quadrant types, that is two quadrant choppers. Class C operates in first and second quadrant. Class D operates in first and fourth quadrant. In case of class C, current can be positive or negative. Voltage is always positive. In case of class D, current is always positive, voltage can be positive as well as negative. Again, these two types, class C and class D, are bidirectional. That means the power transmission takes place bidirectionally, that is from DC source to the load, or vice versa from load to the DC source. Next is class E. This is again bidirectional chopper, that means transmission of power is bidirectional and it operates in all the four quadrants. So this is about the classification of choppers. Next is flyback converters. This is the corresponding circuit diagram. Here we are using a MOSFET. This is MOSFET which is acting as a switch. Vs is the supply voltage. Initially, whenever supply voltage is connected, look at this diagram. V1 is the primary voltage, I mean voltage across primary winding. V2 is the voltage across secondary winding. These dots are used. You don't have to learn the details about the dot conventions. Make it simple. Initially, whenever there are two modes. First, we will talk about mode 1, that is MOSFET, that is say M is switched on. Whenever it is switched on, it is acting as a short circuit. Due to short circuit, the voltage gets developed in the primary, gets induced in the primary as well as in the secondary winding. The polarities are plus, minus, and this dot here I will mark plus, minus. Due to this diode D is reverse biased and as if load is disconnected, but we are using a capacitor of larger value, so this capacitor produces the current to the load. This is the case in mode 1 when MOSFET is on and it is acting as a short circuit. Now mode 2. In mode 2, look here, we are using transformer, which is as if you can say it consists of inductor, and we have discussed the inherent property of inductor, which is storing the energy. So in mode 2, MOSFET M is switched off. Whenever it is off, it is acting as an open switch. That means this connection is open. But due to the property of inductor, the polarities gets reversed. So this becomes plus, this becomes minus, as well as these polarities are reversed. So in this case, the diode gets forward biased. That means it is acting as a short circuit and the current will be applied to the capacitor as well as to the load. This is the way how the circuit operates. These are the corresponding diagrams. Primary voltage is like this. Initially, this was the case when the switch was closed. That means M in mode 1 when M was on, and this is the diagram. This is the waveform in the second part, that is in mode 2. The secondary voltage in mode 1 is negative because we have already discussed there was negative polarity at the upper side and positive at the lower side. So you are getting the waveform like this. This is the waveform of diode current. So this is about the circuit diagram and waveforms of flyback converter. Now we will discuss the operation of 4 quadrant, that is class E chopper. This is the circuit diagram of class E chopper. As shown in this diagram, here we have connected one motor, then RA and LA. LA is the series inductance of motor. Four switches are shown: S1, S2, S3, and this switch is S4. In parallel with each switch, we have connected four freewheeling diodes, that is FWD 1, 2, 3, and 4. FWD stands for freewheeling diode. Now, since it is a four quadrant operation, we'll divide the operation into four parts. First is when S1 and S2 are on. We know that these are the switches, that are designed by making use of power devices like MOSFET, IGBT, or SCR. So, if we switch on S1 and S2, means this switch as well as this switch, whenever any switch is closed, that means it acts as a short circuit. तो यहाँ पे short circuit आ जाएगा, यहाँ पे short circuit आ जाएगा. So the path of flow will be, हर एक केस में मैंने path लिखा है. जैसे ये short circuit आ गया तो current will flow like this through Vs, then through this short circuit, then E to F, यहाँ पे लिखा है मैंने E to F, then through this motor, that means through this inductor up to point G. S2 is again closed, so it will be up to point K, then it will be I, J, I, and then back to the negative terminal of source. This is the given path. In this case, voltage V0 and I0 are positive. So this is the operation in the first quadrant, and in this case, the inductor will start storing the energy. Next, when S1 and S2 are off, that means these two switches are off, then the stored energy which was stored in the inductor will be dissipated, transferred back to the source. So in this case, this transfer of energy takes place through FW3 and FWD4. That means by making use of FWD3 diode and freewheeling diode number 4. So the path is like this: F to G, G to H. So F to G, then G to H, then H to D, because this diode is now in operation. So then through this FWD3, that is H to D, then D to C, then C to B, D to C, C to B, B to A, and plus towards positive terminal of source, then from negative terminal of source through this terminal I, J, and again back to F, because FWD4 has now started conducting. This is the case when S1 and S2 are switched off. That means the energy which was stored in the first quadrant now started sending back to the source. Next, it is quite opposite to that of earlier. That is when S3 and S4 are on. So when S3 and S4, this and this, are switched on, then the flow of current V0 and I0 will be negative. I have already written the path. Same way, it is just similar to that of S1 and S2 on, but only the difference is that in this case flow of current will be in opposite direction. Already मैंने path लिखा है. So V0 and I0 are negative. Then similar to this second condition, that means when S1 and S2 was off. In this case, when S3 and S4 is off, FWD1 and FWD2, these diodes are used to transfer the stored energy in the inductor back to the source. So this path is written. This is the second quadrant operation. So this is about the four quadrant or class E chopper. Next part is SMPS, that is switched mode power supply. From the exam point of view, we may expect the question like this: draw and explain the block diagram of SMPS, or what is SMPS, what are its different types. We will discuss the block diagram of switched mode power supply. As shown in this diagram, initially it consists of one comparator that is designed using an op-amp. At the positive terminal of comparator, we are applying triangular wave. Negative of comparator is connected to output of error amplifier. This op-amp is acting as an error amplifier. We are using one switch. Like the other cases, we know that any power device can be placed over here to act as a switch. So to this terminal, we are applying unregulated DC voltage. This is the switch which can be opened or closed, and it is, let us say, designed using MOSFET. Then this LC indicates the LC filter. So this is the filter circuit. At this point, we are getting a regulated output voltage. R1 and R2 are voltage divider, are used to form the voltage divider. From this point we are picking up the output voltage. यहाँ से हम लोग output voltage ले रहे हैं. This is the feedback connection, and this voltage is denoted by VFB, that is feedback voltage, which is using voltage divider formula. We can say output voltage V0 into this resistance R2, that is V0 into R2 divided by R1 plus R2. This is the value of feedback voltage. This feedback voltage, which is taken from the regulated output voltage, is applied to error amplifier. I mean positive terminal of error amplifier. To the negative terminal of error amplifier, we are providing reference voltage, that is grounded in this case as shown in this diagram. So that is 0. Now output of this error amplifier is connected to the negative terminal of comparator. How the circuit operates? This is the triangular wave which we are supposed to apply to the positive terminal of this comparator. To the negative terminal we are connecting output of error amplifier. Now this is the typical diagram of output of error amplifier, which is the square wave signal. We'll consider one condition. If V0 decreases because of certain thing, because of say variation in the load or so on, if output voltage decreases, मतलब ये voltage, this voltage decreases, then यहाँ से हम लोग ये voltage pick करके VFB generate कर रहे हैं. So if V0 decreases, VFB also decreases, that is feedback voltage decreases. Due to this, the voltage which is applied to the positive terminal of error amplifier will be reduced, will get decreased. ये reference तो fix है. So output of error amplifier will also reduce क्योंकि ये positive का voltage कम होगा तो output of error amplifier will reduce. अब ये डॉटेड जो लाइन मैंने बनाया है, दैट इज आउटपुट ऑफ एरर एम्पलीफायर, ये अगर रिड्यूस होगा मतलब ये लेवल नीचे शिफ्ट हो जाएगा. सो इट विल जनरेट मोर ऑन टाइम. जैसे देखो ये स्क्वायर वेव में, इन दिस स्क्वायर वेव आई हैव शोन दिस इज द ऑन टाइम, दिस इज द ऑफ टाइम. तो ये पल्स अगर आउटपुट ऑफ एरर एम्पलीफायर इज रिड्यूस्ड मींस दिस वेव विल बी शिफ्टेड डाउनवर्ड, तो ये विड्थ बढ़ जाएगा. दैट मींस ऑन टाइम पल्स विल बी मोर कंपेयर टू द ऑफ टाइम पल्स. सो इट विल इंक्रीज ऑन टाइम. This upward arrow indicates that the value of on time is increased. We know that duty cycle is given by T on divided by T on plus T off. So if on time is increased, duty cycle also increases. Due to this increased duty cycle, the current of this switch or transistor, power transistor, gets increased, which will increase the output voltage. This is the way how the compensation is done. This we discussed whenever the output voltage is reduced. If a reverse case, if output voltage increases, then reverse case will happen, and accordingly the voltage will be adjusted. Now in case of SMPS, there are two major types. One is boost SMPS and another is buck SMPS. So this is just the quick revision of this particular unit. So dear students, thanks a lot for watching this video.